Hello, inspiration. If you are talking, I can't hear you though. It seems you're muted.
What the actual fuck? I've been muted all this while. Crazy stuff. Yeah, sorry about that. Yeah, that happens sometimes. Last time was 20 minutes in. Today's 10 minutes in. How? Nobody said anything on the timeline. Crazy. Sorry, guys. Yeah, um, we're back now. So let's do what I've been saying all this while. I can't remember what I was saying, but let's just get started. So, we want to do um an anchor, a couple of anchor projects that might build everything on top of each other, right? So starting with the counter examples, that's someone's capstone project. Counter examples, the vault, the escrow, and I think I already explained what the fundamental concept of those are yesterday, right? So let's just get started first. So I want to get to my document and I want to do anchor. Let me create a new folder. Directory anchor basics. Yep. Then cd anchor basics. Yep. Then do what my anchor version. Anchor. Sorry. Yes, anchor. Yeah, I think so. Anchor version 31. 31 is good enough. There's 32 is the latest, but 31 is stable enough for what we're doing today. Let's do anchor new, and I like to use multiple templates. Like templates multiple means it to arrange your folders in to arrange your directory in a more better hierarchy. So let me show you what that is. Anchor new help. So you see template. So there's single. So your program uses a single librs, but if you're using template multiple to have multiple files for instruction folder, state folder, whatever. Then if you'd like to use Solidity, I don't know why you'd want to use Solidity instead of Rust, but you could do that also. Stream. So you could do that also. Yeah, so that's what I want to do. So let's do Anchor New. What do you want to call this program? So let's call it the Anchor Extravaganza, whatever that means. I think we can use an iPhone instead of, yeah, PTSD. Templates, multiple. And I want to use PNPM, package manager, PNPM instead of NPM. Yeah, I think so. Templates, not templates. Templates multiple. Package. I think it's package manager together, not package hyphen manager. Let me see. Package manager. Okay. Nope. It's so what's the I'll just use wait, I'll use did they remove package manager? Package PNP. Let's do hyphen then hyphen. I don't think that will work though. Yep, that's the package. Let me just remove that for now. We can switch to PNPM inside our program. Template multiple. So I'm supposed to do anchor init instead of anchor new. So that was the problem. Template package manager works. So I'm supposed to do anchor init. Yeah, package manager. Let me do anchor init, then help. I need that package manager. I don't know why. Just feels good. Anchor init, help. So there is a templates, package manager. I was correct. So why was it? Did I spell my package PACKG wrongly? Let's see. Okay, I did this, especially this. Yeah, and we are good. First bug. So is this thing too loud? I think the music is too loud.
What is the meaning of extravaganza? What was that?
Extravaganza. Let's see. What does it mean? Who knows extravaganza meaning? Yeah. A composition as a music, a drama, dance, politics, blah 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 blah. Just a lot of things. A lavish, spectacular show or event. So I'm doing a lot of, not a lot, but like three different anchor projects. Might be inside the same program. So what we'll be doing today is counter, escrow, vault inside the same, might be inside the same program, might not be inside the same program, but who knows? So yeah, that's what extravaganza means. So see the code anchor extravaganza. Yep, and we are in business, baby. Yeah. What's my CPU clocking? What's going on? Yeah. Okay, I'm good. I think I'm good. Then I want to show this at the top all the time. Okay, so now let's get started with what we want to build. Firstly, we want to build a counter. What's a counter? Counter is, I'm gonna just count. Yeah, so now let me explain what else. Inside the programs folder, we have Anchor Extravaganza as one program. So inside of it, you see the folder is structured, instructions, then state, constant if you have any, errors if you have any, debarrers. So this gives sanity to the developer instead of having every time a long debarrers. But for the purpose of this program project, this is an overkill basically because our counter does not need to have all of this. But yeah, no problem. We can move around that and solve that. So let's see. 1 minute. I have power issues on my monitor. Yeah, I'm back on. So it created a package for, it created a program for us, a program template for us, and it gave us this ID. So now if you look at it, this looks kind of different. You're creating a new program, and you already have the program address without it being deployed. Why is that? Like I said yesterday, are we separating the program and front end? We'll have a client test. When we get there, let's get here. Let's start what we're doing first. So I was saying yesterday that everything on Solana is an account, right? So basically that applies here also. You are deploying your program states, your program code, your program logic, and there's an account that is responsible for that. So you are writing data to an account, and this is the account that are writing the data to. So the account is created inside. If you check targets, then deploy, yeah, and you have a key pair. So this is the wallet address of this key pair. This is a JSON key pair. If you want to confirm, you can just do Solana address -k. Where is the keys? The keys are located at target, deploy, then what's the name? Yes. So we have a DV58 blah blah blah. So that's the same thing as here. So this is the key pair. This is the wallet that is the account that will store your program state. So that's basically it, your program logic. So yeah, so that's what this is about. I'm not declaring this right here. So even though this program does not exist right now on chain, we already have where it should live. So now let's get started. We have a function called initialize, and it's doing this initialize handler. There's this handler inside of the initialize. So what this is this handler is coming from these instructions here. So if you check source instructions, you see an initialize. So there's a handler here. Yeah. I don't like doing it this way, but you could do it this way also. You have your struct here, but this does not give you the beauty of how powerful Rust can be. I'd like to take you down that journey 1 minute. So if we have this, instead of having this handler here, right, we could do something similar with an implementation. An implementation is like, I don't like to use the word classes because I don't like OOP. So it's like you have a class and you have a class is like an is a you declare a new object, it's like an object instance, right? So all the functionalities that that object should have. So inside the class, you could have other methods, other functions inside that class, right? So you can do that with Rust too. It's called an implementation. So implement. So because we're using info, should I get here right now? Let me just show you what that is. I'll explain it. Initialize, then it's taking the same info, lifetime. Yes. So inside here, I can now create a pub function that says undo initialize. So this one is taking just, let's say, self. It's taking it. If you want to mutate itself, but I don't think you're mutating itself. Just taking self, whatever is in self, and it's just returning a result. Same result that is down here, right? Returning the results. Yeah. So you can put this inside it right here. Device. Sorry about that. So now I don't have a CTX of program ID now. I have a create ID. Let me use create ID. So this whole thing is a create, right? You can have the ID of that create. Implementation struct takes in, right? The reason why is because of this. I specify that parameter, lifetime parameter here also, and I'm not using it anywhere. It's never used. Okay, because I'm not using it, let me remove this for now. For now, we can remove that for now. We're not using any lifetime for now, so let's just remove the lifetimes, right? So now we have a clean implementation. So if I come back to librs inside my initialize function, so we have context, right? So I can now access that same function that I created. Now I can access it through context. So context.accounts dot handle initialize, and it will basically do the exact same thing. CTX. Yep. Sorry. Self. 1 minute. So I can remove this. It's not taking anything. It's not taking any variable, right? So just undo initialize and return our OK at the end because it is an expecting to return a variable. The result type CTX account and initialize. Can't move because it is behind immutable ref. I'm not moving anything. CTX account. A minute. Let me fix that here. Initialize. So what's the problem? Self. Borrow a reference to self instead of having self. So okay, it returns. All right, so that solved the problem, right? So what I just did was just, I don't like having this calling the instruction directly from wherever it is created. So this is from instructions folder because we have a mod. So how does all of this work together now? If every folder has a mod rs, a module is called a module. So this is one module. So the module entry point is this mod rs, and we're defining that inside this mod rs we have a public module called initialize. So I'm importing this initialize here, and I'm re-exporting it. I'm re-exporting every single thing that is inside it. So that's what I'm doing here. So pub mod initialize and pub use initialize. So I'm re-exporting what I just imported. That's basically what I'm doing here. if you go check the state, that's the same thing that I did, but we don't have anything inside state yet, so state is empty for now. Then, so inside my initialize, so that is why we can have this, yeah, initialize and handler, because the handler is from this initialize function here. If I comment this, if I comment this and I come to librs, handler will throw an error because there's no function called handler inside that place anymore, right? So I like to do things this way. Keeps your code, especially if you are dealing with large code base, right? It keeps your code structure clean. You're handling instructions here, and all your functional functions are what's it called? An implementation of your account, right? So that's basically what this is just about. It's just ergonomics, right? So let's run this test. We have this. Let's deploy the program. We are on. So Anchor first. This is Anchor build.
The anchor need ish.
Sorry, my bad. Anchor build is to download like 1 million packages that are required by Anchor to do this. Sorry for that. Just have to say it. Yeah, to download a lot of things. It take a bit of time, so that's what I was trying to point out.
So is it like the instructions like what you set in order to uh like what runs the program? Like this is what the guideline for you to run this.
What's that? What's the question? I did not get the question.
I mean the instructions
Hmm.
before is it like what sets the guideline for what we run in the lib
This one.
.rs?
This one.
Yes, like the instruction. This instruction we just set now in the initialize.
No, this is just a function that does a console.log greeting. So greeting from your program ID. That's what it will log as when we test this function.
So I think the approach inspiration is trying to like take just to like modularize stuff. If I'm
Yeah.
correct, to
Yeah.
create some sort of like if you've worked with like JavaScript or other objects oriented program where you have classes and all the functions you need will be inside. Then you can now reference it in other places.
Yeah.
Oh, makes sense, makes sense. So you just have to like import it into this other function that you
Yeah.
have.
Yeah. So I don't like when we are importing it from. So instead of saying this one is like saying someone trying to join, someone trying to join. Okay, bit ciphers in the room. So this one is like saying import, if you are coming from TypeScript, import blue from from red, right? This is like what that is saying. Then inside there, I'm now doing blue blue say color. So because you imported blue from red, right? But what if you could just have you pass in whatever you need inside this instruction handler, then you call it from inside the context instead of importing blue separately here on its own. So the blue that I need here is already inside the CTX because I created it inside the CTX instead of having it as a separate function. So it's a function, but it's not outside on its own. It's now a function inside a big container. So inside this initialize implementation, so I can now call and do initialize here as a ctx.account. So because everything I are passing here as a context, it will come in the accounts handler. So it will come in as an account, and I can call the handle initialize function that I created here. Because everything I'm doing here is basically accounts. When we start writing the accounts, you understand what I'm trying to say. But for now, just have it like that for now. When we start writing other things, you will get what I'm trying to say. So instead of me writing blue dot color dot say color, I just want to remove this say color totally and get the color from the function that is calling this guy. So if I why are you taking forever to download, bro, crazy, crazy stuff. So this should throw an error because I've removed that under the but let me bring it back in the yes, let me bring this back. If I do, so if I run libres, is there any error? No error. If I run anchor build now, again, so not download, this is just build. So no errors, right? If we come to our test, where is the test? Where is that test? Well, let's deploy before testing. So we're deploying to DevNet. I don't want to test on testnet. I don't have that strength. Let me just deploy to DevNet. I don't want to set up validator and crash everything that I'm working on. I'm managing my PC. Thank you very much. Yeah, so let me do, let's check the test first. Tests inside your test folder. So Anchor creates all of this for you when you're doing initialize. So this one is calling, this is a this is a TypeScript test, right? So it's basically TypeScript. Everything you're seeing here is TypeScript. And what this is if you check, I think cargo toml somewhere, anchor toml, where's anchor toml? Anchor.toml, yes, this guy. You see what is happening. I say we're using TypeScript Mocha. So Mocha is the testing library we're using Mocha as a testing library. Yeah, so that's basically what this is about, what I'm trying to show you now. That's what this is about. So we're using Mocha to test, write our test here. That's why we have access to describe. So describe is from Mocha. We have it from Mocha also. Like this, it is a test function, right? So we can have it is initialized. It is initialized. So this test will run successfully only when it is initialized. That's what I call this test, right? So if I run, I'm not deployed. So let's do Anchor deploy. Let me airdrop myself. Solana airdrop. I want to sorry airdrop to my main wallet because I'm specifying that my main wallet I'm going to test this program, right? Yeah. Let me just try that again. And if two does not work, I'll go to one. The RPC is killing me. Yeah, two worked. So now I have 26. So I'm rich in DevNet. Excuse me. So let me run this test. So what we should notice here, if you check the Explorer, you would notice. Well, let me just deploy first before. Anchor deploy. Oh, sorry, my bad. So things you need to take note of. We are not on localnet, we're on DevNet here. And also here, programs.devnet. That's what happened there. So because we're testing in DevNet environment, so I'll use DevNet. It's trying to connect to my local host RPC, and I'm not running any RPC locally. So let's move to DevNet. Yeah. And it's telling you that the wallet I want to use for this program deployment is the general wallet, my default wallet on my computer. This is where it's located. So if you have my computer, just look for this directory and you can have access to my wallet, right? Yeah, so the program will deploy successfully to this address that we created. Now I told you everything's an account. So we immediately you created your Libres, immediately you created your file, your Anchor project. We had this guy address, and I told you where that address came from, right? The address is from targets, then deploy, and you'll see it here, Anchor extravaganza keeper.json. That is the account that we owed your program logic on chain, right? So this is what you are paying for rent. This is what you are paying rent for, because this will now hold the state of your program, the logic of your program, your code. This is where it will live. So the address of this key pair is this guy. And how do you validate that? So you can just use this Solana account lookup, Solana address lookup. Solana address, the target is this guy, right? So where is the key of this address that I'm looking for? So if I do this, it will show me the address that is at this directory. And if I want to check everything that is happening in this account, right, so I can just do Solana account. If I want to inspect your account, I can just copy my wallet address here, paste the account here, and to tell me every single thing that is going on in this account because I have access to the RPC. Yes. And now you can see that what I was explaining yesterday, right? So this is the account that we created. The owner is the BPF loader upgradable. That means there's a smart contract and there's a program on it, and the program is upgradable. Sometimes try again. No. So there's a program on it, and the program is upgradable. Is it executable? Yes, the file, and the file is executable. Let me remove this for people that want to. No, I just made myself bigger. Come back, come back. Come back, bro. Maximize. Yeah. Then I just messed up the arrangements. Yeah, all good. I trying to make sure that if people are on Twitter, they will not be able to see this because I will move this small account over to, or I can just make it invisible for now. Spotlight, yes, I think. Can see me, right? You can see me. If you can hear me, confirm. If you can hear me.
Yeah, I
How
can.
about
Yeah.
okay? How about people in the audience? Let's see people in the audience. If you can hear me, because if you remove yourself from the stage, most likely you'll not be able to hear. Let me check Twitter. If I can hear myself. So Twitter, can you hear me now? Can you hear me? Yeah, yeah, I can hear myself. Yeah, we are good to go. So let's just continue what we're saying. So now it's telling you this is the rent port for this account, right? So and this account has 32 bytes, 36 bytes, right? So there are 36 byte length on this account. So that means there's data stored on this account, and this is data that is stored on the account. This data is basically this or everything we wrote here in bytes. So that's what it is, right? So yeah. So we just created an account and we just inspected the account. So you can do that with Solana account, then put the address. So you can also use a shortcut that I like. It's a long cut, but not a shortcut. So I do Solana account, Solana account. But if I don't know the address, let's say I'm on a machine, I don't know where the address is. I can just look up the address with this. I can nest the function here. Solana address. Yeah. So I can do Solana account, Solana. So Solana, whatever Solana address gives me, it will spit it out to the Solana account. So I can inspect it fully that way. Because I don't know what my Solana address is. So I want to inspect the Solana address on this computer, right? So that is a normal account. That's a balance of 25. So the owner is system program. It's not executable. There's no program logic on it. It's just a normal regular wallet address, right? So that's basically how to use. Just get familiar with Solana CLI to make your life easier. Yeah, so back to what we're saying. So let's now, we've deployed the program now, so let's do a test. So when you're writing your test, if you don't want to, since I've already built it and I've deployed it, you can just do anchor test, then skip build, then skip build and skip deploy, then yeah, so to skip, it will not build it again, it will not deploy because you built and deployed already, right? So yeah, our transaction was successful, the initialize was successful. If I come over here to the Explorer, we have an Explorer, soul scan IO. Come over and drag that here. Why did I just do that? Yeah. Soul scan devnet. Give me devnet. Then if I paste this over here and I go to the transaction, I want to check the logs, right? So we said to log out two things. So we logged out greetings from the wallet address from the program ID once. Then we logged it again, greeting from the program ID a second time. Why? Because we did
Because you are calling two functions. Oh,
yes, yes, yeah. I'm looking at it already, sir. So because we did this here one, this was the first one,
yeah.
and this is the second one. So if you enter this instruction handler, you see the first time we did this one, it sends greetings from crate ID. That is basically the ID of this crate. And we have a second function that says greeting from same thing, CTX or program ID.
Oh my
They
God.
the same thing. So there are different ways to get your program ID. This one way. You can instead of having ID as a function, you can also have it like this ID. This works also. Same thing. Same thing. So let's leave it as this. So this one will convert it to a pub key. This other one will leave it as bytes. Don't leave it as bytes. You do this like this. So if you over on it, to give you as bytes. It's actually still a pub key too. It's still a pub key. Both of them are pub keys. Yeah. So anyone wants. Okay. So now let's get into. Is there are there any questions? Questions, suggestions, additions, subtractions, multiplication.
Yeah, not from me for now.
Okay. So let's get on to the meatier part of what we're doing now. Now let's get into writing a state and a capital. Ha ha ha. Mind you, logs are expensive. If you check this, if you check the Explorer now, you'll see how much CUs you consume. 5,633 CUs out of 20,000. Out of 200,000, you consume 5,000 just to create and write something and say hello world. If I remove this hello words here now, I remove this hello words, this one and this one. If I save, if I now I'll just do anchor test because I want it to build and I want it to deploy. So if I do anchor test, to first build it. After I have built it, there are no problems. It will now deploy it. So now it's deploying it. But if I want to skip, I'll do skip build and skip deploy. So now let's see if the deployment goes through. Most likely, most times it doesn't work exactly until you do it again. But let's see if it works now. 190 transactions just to deploy hello world. Now I know Soland is pain. Did it deploy? Yeah, it deployed. And we might have an error. Okay, we don't have an error. So if we check this one now, check this one. So this one was using. So the idea is to write efficient programs, right? You don't want to write programs that will be expensive and people will be paying high amount of gas when you could have reduced the gas that was consumed. So this consumed 5,633 before. So this new one is consuming how much? Just 186. So you see that by logging things to the console, you are consuming a whole lot of compute units and it will be expensive for users to pay gas. You get so when you are done writing your programs, you want to remove all your messages. If you do any message that when you are debugging, once you are done and you have tested everything, everything works. When you are deploying, remove your messages so to save gas. Yeah, so that's that about gas.
But why do we have a lot of transactions when we are testing results?
It's because Anchor is doing a lot of things for you under the hood.
Uh,
So Anchor is a framework. If you do the same thing with Pinocchio, it will not be as much as this at all. So it's because you are using is this still show I don't think the log has gone.
yeah, yeah.
Yeah. So it's because you're using Anchor, so it's doing a lot of things under the hood for you. So you
We,
can use yeah, go on.
we are having like two signature. This five is different from the first one we got. Like why?
This is a transaction hash, like the signature that your transaction was sent. I sent the transaction at different times now. So this transaction can never be the same as this first transaction. I commented this message and I rebuilt the transaction and I tested it again. So this is
Okay,
not a
for
tra-
every build, you have like a hash, like using tracking that transaction, that particular build.
no, every transaction you send has a transaction hash. So what we did here, if you check out test, we are doing CTX program.method.initialize and we're calling RPC. When you call RPC on a function like this, that means you want to send the function. So I'm sending this function. That's basically what I'm doing here. So I'm sending this method. This is program method initialize because we call the method initialize, right? If I do RPC on it, that means I'm sending the transaction. So if you check RPC here, RPC option, promise of transaction signature. So I'm doing a promise. I'm doing an asynchronous function and it's returning back a signature and the pub keys of that transaction. So it's because we sent a transaction to the blockchain. So we need to have a transaction hash for the blockchain for that transaction, right? So that is what this is because we log it out here, your transaction signature or transaction hash, if that's what. But this is not it's an hash is signature. It's not hash like in EVM world. But that what that is, right? You understand now?
Yeah, yeah, yeah.
Okay. So now let's get into writing the program for a counter. So, like I said, you don't store things on. the blockchain, right? So you cannot come here and say, let my name equals Tunde, assuming that is my name, which is not. Say my name equals Tunde, and if you are from EVM, like assuming this is a global function, even if I make it a global function, a global variable, there's no way I can read this Tunde thing. You could, because it's part of your code, but it is not a contract method. There's no method for me to read this Tunde string on the blockchain because it is not, I don't expose it as something you can see. So I'm not saving, you cannot save things on your program, inside your program code and expect to see it outside. If you did EVM contract, you can just specify a map or a string, and in Remix you can check that string that you wrote inside your program. If it's a public function, right, you can just check it on the Explorer and see that, okay, this is a string here. But no, on EVM, sorry, EVM, on Solana, you don't store things inside your program logic. It's not, if you store anything inside your program, it's not it's not public. You cannot get it back. You see, this is something you want to use in your front end. I want to get the user's name. You cannot get this on your front end because there's nothing that will expose this guy to you. So you don't store things on your program. So what you want to store them in is called accounts. So you want to store things inside your account and you create an account. So let me do state now. So there is this everything is by Rust, right? So you write a struct. How do you write an account struct? A state. We're creating a state now. So pub struct I call it counter struct now. Then I can just say pub count, pub current count. Current count is of type U64. How that is 64? U8. Give me U8 just from 0 to 255. So current count is U8. This is a struct. I've created a struct. I can now make this into an account with Anchor's help. I can make it into a struct that can be deserializable by Anchor. So first thing I need to use Anchor prelude. Use Anchor lang prelude, and everything inside this prelude does a lot of things. And our program size is large. So then I'm coming here and I'll use this macro accounts. The accounts, I think it's this one. No, not that one. Accounts. I think this one. Is it this one? I guess so. Yeah, I think this one. So now I'm telling it that this account should be serial. It is an account now. I've told Anchor that this thing is an account. Just because I use this Anchor macro, this account macro here. So and this account is deserializable as an account, and it can be serialized and deserialized as an Anchor struct. You can clone it to have a discriminator. A discriminator is a pointer to tell you that this is what this is. Like it will have a number on it. Okay, maybe number 0 or number 1 to be a discriminator. But Anchor uses it by discriminator. So it's an array of numbers to show you that this is the identifier of this struct. And to have an owner. So that's basically what it's doing. And it is doing, isn't it? That's all we're doing today. That's more in depth. So now, yeah, we have this guy. And we need to know, okay, we'll talk about that. So we have this counter, and the counter can take a current count, and the initial count is 0. Like if you create a variable, an integer variable, on-side integer variable starting off at 0, right? So I come to initialize now. Now we can have our accounts. So the first account we want to know about, we want to know who exactly is signing this account. So let's do we want to know who exactly is signing the transaction that is coming. So this is all the accounts that you are sending from the client. This is what I want it to look like. The struct that will tell me how the accounts that I'm sending from the client will look like. So I'm creating a struct. The first value inside the struct is call it a signer. Might be a signer, you might call him a payer, whatever. And this signer is a signer. The signer and a signer. You can just leave it as a signer like this, right? But Problem with this is it will not have you will not have the lifetime that you want. Because let me over on sign now. Missing lifetime parameter. When you were looking at the Rust book, they talk about lifetime, right? Lifetime shows, yes, it tells your compiler how long do you want this variable to exist for. So if I'm using a lifetime of a, so whatever is that lifetime name on top, and it sees that okay, there's another a here, another a is here, it will know that this all of these are using the same lifetime. So now, so let's call the lifetime we want to use here. Let's call it an info lifetime, and you define
Apart
lifetime.
from info, is there any other lifetime people do use? Or it's just like an alias?
Yes, an alias.
Okay.
So if you want to use a, you can use a, and you write your. So because I'm defining an implementation here, I need to tell this implementation to be aware of the lifetime also. But we're doing Anchor, right? So let's use what Anchor everybody's familiar with in Anchor. Info, let's call it info. So it's an info lifetime, info, info. Yeah. So now that fixes the error of. So you just know that you are putting info here, you are putting info here also, just for ergonomic side. So I'm telling you now, this account, this first account must be a signer. This account, the first account I'm sending is a signer. So the first account that there must be just basically there must be a signer account inside this when you're talking to this instruction. Whenever I'm coming to this instruction, I must have a signer account. And there are other macros also, anchor specific macros. And I will direct you to the Rust book, anchor book in a minute. So now you can now specify that this is an account, just like we did here in our state. We specify that this is an account, right? So you can also specify that this signer must be an account also from the client. So this is an account, and you call it like so. Then you now specify what are the characters that you want for this account. If this account does not have this character, throw me an error. So I want this account to be mutable. That means a mutable account means I can change something inside it. You understand? So means if I'm a signer now, I'm sending you my account. You want to be able to change something inside my account. That means you want to, for this and in this situation, what you want to change is the lamp post. I want to change the amount of money I have inside my account because I'm signing the transaction. I have to pay for gas for that transaction. So
Yeah.
we are going to subtract some amounts from my balance. So that means I must be a mutable account. So I must be mutable, must be able to remove money from my account. So that's basically what that is. That's simple. I'm telling it, yeah, a mutable variable reference a pointer, blah 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 blah. Just telling you this is mutable. That's the type of account it is. It must be mutable. Then now also you want to send me a counter account because we created a counter account already, and that is of type account, just a basic account, and we also have the info lifetime that we created and a comma and the name of the account. We call it counter, right? So you can import counter from create counter. Yeah, this was the counter that we created inside mod rs sites. So we have this struct counter, and we can sorry, yeah, and we can use the counter that was created at streaming. And we can use the counter that was created. Yeah, so we just imported and we're telling it this is a counter type. The counter attack, a counter, that's a counter attack, a counter account. Yeah, so this is a counter account and it has a variable called current count. So for this one also, if there's a value, so this one is the signer struct. If there is something else here, you just pass that one, but there's nothing else there. It's just an info. It's not taking anything else. So this account must take in a lifetime. I must take in what type of account is this guy. So the type of account is a counter account. So we are telling you when you are coming to me to communicate with this instruction, you must pass a signer. I must pass a counter account. So the signer account and the counter account. So know that we also want to modify the variable, the value of this account because this is an account initially, right? Counter. This is taking starting off at zero. Then when we increase the counter, I want to increase the value, reduce the value, all those stuff. So it must also be what mutable, right? Yes, fundamentally it must be mutable. But now, in this sense where this account does not exist, it does not exist at all. So someone has to pay for the account, someone has to create the account, right? So that's where we use this keyword in it. So we use an init keyword to tell you that okay, this account that I'm passing that has not been created before ever. Nobody has created the account ever. But you're passing it to me inside the instruction, and I'm the one to create the account. I'm the one to initialize the account basically. So that with that, because you're passing initialize, you have to tell us who is going to pay for this account that you're passing. So it's looking for a payer. So you do payer is in this case the payer is the signer. The same variable here, okay? Payer is signer. And the beautiful thing about this is you can put an expression here. Let's say if signer then return signer. It's just you can write an expression there. So but let's just use signer. I'm not doing any condition. So it's still you're writing Ross, you can write your Ross condition inside this account constraint. So now we have a signer already, but it's still complaining. Signer. Still complaining. Why is it complaining? Let's check. Say space must be provided with initialize. So now that you're telling me that I will create the account, I need to know the space of the account so I'll be able to pay rent for the account. So you need to tell me what space this account is. So space is so for Anchor, every account they are creating will have a minimum of 8 space to take the discriminator. Discriminator is what ID. So the ID is a 8-bit discriminator, 8-byte discriminator. So I explained what 8 bytes, what that 8-byte thing looked like yesterday. If I can get Excalibur, let me see a difference. Excalibur.com. If I get yes. So this is what an anchor struct is. What an anchor discriminator is this guy, but it's not a 32 byte, it's an 8 byte. So this is what, and that will look like this. This would look like. So this one can only go from 0 to 255. Abi. So let's do 0. Let's do 255 here. Let's do 3 here. Let's do 250 something, whatever. Blah, blah, blah. 0, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I think it's yes. 1, 2, 3, 4, 5, 6, 7, 8. So this is what a discriminator on our core account look like. So this is an ID. So every account they are creating, we have an ID inside Anchor for Anchor to know that this is the ID I'm talking to. So this is what a discriminator looks like. So sometimes it might be 0 year, 0 year. It's just Anchor will create a discriminator for you, right? So that is what a discriminator is about. This one is discriminator, nator, or identifier. How it's called. The discriminator is basically an identifier. Yeah. So it has 8 length of 8. Let's get back to it. So we have already specified that it must have a space that will contain those 8 discriminators, those 8 bytes for the discriminator first. So I've already specified that it must contain those 8 bytes. Next thing we're going to specify is so the size of creating this account. So when we enter counter, we'll now see what is the size of a U8. What size of a U8? Just one U8. This U8, don't forget everything is U8 inside a U8 byte, right? Everything is U8. So U8, this is one U8. This is another U8. This is another U8. This is another U8. 5, 6, 7, 8. So these are 8 U8. That's why we have 8 here. 8 U8, right? So the basic units on for numbers and size and bytes is U8. So and what's the size of this U8? What's the size? What's the size of this U8? Who knows?
I think it's not. Can't see. Can't see. Okay, it's one
Now,
times 10 raised to 8 or thereabouts.
Is 0 to 2 or 5.
okay, this is it now. Now this is 1. This U8 is 1, Abi.
Yeah.
This another U8 is 1. This another U8 is 1. This another U8 is 1. This another U8. So the total size of this U8 is what?
That's 8.
8. So in this case, what is the total size of this U8?
That'll be 8.
Again, this is 1 U8.
Mm-hmm.
This is 1 U8.
Mm-hmm.
This is 1 U8 again. This
Mm-hmm.
is 1 U8 again. This is
Yeah.
another 1 U8.
Yeah.
Another 1 U8. 1 U8. But the total, because there are 8 U8 here, the total size is what? 8.
8. Yeah.
So now, how many U8 are here?
Since we have 1, that would be 1.
Exactly. So to initialize here, so plus 1. So that would be the size of this account that we're creating. So it will have a space for the first 8 byte discriminator and a space for the one uh assigned 8 integer. If we want to add other things to it, let's say we have another guy that is called Bob is alive. Is alive. Let's give it on a boolean bool. This boolean is also taking in 1 byte. True or false, blah 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 blah. So it's just 1 byte also. So this one would be 1 plus 1 would be 2. So we can have 1 plus 1, right? So that's how to calculate the size of the account. But there's a that's good, right? That's we now know how to calculate the size of an account. If it's a pub key, if it's a pub key, let's do pub my account. Might have cap lock on. Pub my account is a pub key. I told you the size of pub key yesterday. What is the size of pub key? I just showed you now. So this is pub key. What's the size of this pub key? This is a pub key. What's the size of pub key? Who wants to
It's
go?
32 now, abi?
Yeah?
32?
Yeah, exactly. So 32. So if we want to calculate the size of this one, because now we have 8 before, plus 1 plus 32. So yeah, we have 8 plus 1 plus 32. That's how calculate the size. If it's a U16, a U16 is basically 2 U8, right? Oh, that's yes.
Yeah. Yeah.
A U16 is 2 U8. So that would be 1 times 2. U32 will be times so whatever. Then, but let me get the reference to that material. Calculating account size on Solana docs. Anchor. I should have used Anchor, but Solana account model, blah 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 blah. Yeah, blah, 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 blah. On Anchor. There's no account size. Variable. Anchor Solana. I'm just combining keywords now. Okay, let's see what this one will bring up. Yes, this is what I'm looking for, but I'm looking for the exact doc. It's on a document page. Let's check. Let's check Anchor Docs. Should be on Anchor Docs, but I don't want to look for it. That's just it. Country Anchor Docs. Why is my cap locks turning on? Anchor Docs. So let's check. No, it's not. Yeah, let me increase the font size a bit. So when we get to program structure. So calculating the size. So this one is 8 plus 8. Reason why there's an 8 here is probably because there's a U16 somewhere. Let's check new account. Inside your new account. Yes, U64 is 8. 8 times 8 is 64. That's why we have 8 plus 8. If it was a U8, it would be 8 plus 1. So 64 is 8 times 8, right? If it's a U16, 8 times 2. So that would be 8 plus 2. You get, but let me look for how it's actually calculated. Program ID of
So the U is the 8. Then if it's 8 is now, which is U8, is just 8
one.
plus
So that's
just
one
1.
size. Exactly. So U16. So the basic unit is 8, right? So the 1 8 is 1. 16 is 2 8, right? 64 is 8 8. 32 is 4 8, Abi. I think that's yes, 3/8 rather. So it's just calculations, right? Basically. So you divided by what to give you that U16, U34, or U32. I'm looking for the calculation. There's a place, account type, account basics, no, not tokens, program structure, program idea of not this one. Is it here? I will look. Can someone look for it in the chat? Is Collins here? Collins is here. Collins, please help me look for it and send the link so everybody just see. Look at what I told you. These are the discriminator. So the discriminator is 1, 2, 3, 4, 5, 6, 7, 8 bytes. So that's why we have 8 initially. So this is the discriminator of the account. Blah, 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 blah. Account, yes, let's see account space. Yeah, exactly. This is what I was looking for. So one bool is one, still U8, right? Assuming it's U8. A U8 is one size. U16 is two. U32 is four. Because that's four times 8 times 432. U64 is 8. U128 is 16. So now, assuming you have an array of whatever. So let's assume an array of an array of 8 bytes now. So if the length of that 8 bytes is, I just gave the answer. Don't worry. Okay, let's use this one as an example. We have a U16, excuse me, and we have a 32 here. Okay, so what's the space of this U16? So we have one U16, no, 32 U16. So why is it 32 times 2 U64? That's not what they're trying to say there, though. Okay, yeah, they're trying to say if you have whatever state you have here, if it's, let's say, 4 is a U8 here, and you have a length of 5, so a U8 is 8 times 5. So whatever that size is, will give you whatever is here. So a pop key has 32 length. A vector of, okay, for a vector now, you have, if it's a vector, you first put 4 before the space of the vector. If it's a string, you also put 4 before the length of the string in byte. If it's an option, that's just basically what's you want to get calculation of how size is. But instead of you calculating this manually, which I would have loved to see you painfully do, there's a there's an easier method from Anchor, and that's called have this init space. Init space. Is that how to spell it? Init space.
I think, yeah, this in this space, yeah.
So you derive init space. So you
Okay,
can
yeah, yeah, yeah.
derive init space. If you derive init space here, it will help you calculate the space that is required. So if you come to your librs here, so instead of writing this, you can now do, instead of 1 plus 82, you can now do from this counter, right? Counter init space soft. Oh, where did I put it? My bad. Z. Yeah, Yawa. So that's it. So it will give you the space of the counter. And if instead of writing 8, if you don't know what the space of that 8 is, if you don't know, assuming you don't know, you can still write counter discriminator. So if you have that one, you can have, so you know what the site, okay. Discriminator dot len, you have to do a len on it. So you do a len to get the length of the account, the length of the discriminator, then the space that is required for, but we know that it's 8, right? So let's write 8. Thank you very much. Is it capital letter C for the counter or is it small letter C? I think it's capital letter C. But let me check. Is it small letter C counter? Nope, it's the capital C. So yeah, we have that. So now we need one more thing. Like I was explaining yesterday, we need to know. So forget that I said this for now. Let's still use we know that it's 32 that is there, right? 32, even though we don't need it for now. So let's still use this guy. Okay. So now we now also need to know. I told you when we are creating an account, we need to have some form of ID to be able to look for that account later on. I was talking about PDAs.
Yeah.
Yeah. Sorry, give me 1 minute. Yeah, I'm back. So I was what was I saying? Yeah, PDAs, and there has to be some seeds for calculating PDAs, right? So we want to know what seeds are you giving me to create this account with? Basically, that's basically what I'm saying. So we need to know what seed I will calculate in the account with. So now we need to tell it. You have the space, you have this now, you have to have the seeds is an array. Then the seeds. Okay, when you have coming to that. So seeds. So what seed you want to use for it? Let's call it counter. So let's call it. We want to call it counter account. Whatever you want to call it. Let's call it just counter, right? But we cannot just pass in a seed, a string there, because it does not understand string. You only understand bytes. So we have to convert that string into a byte. So you can just use this B in front of it and to convert your string into a byte buffer. To convert it into byte basically. So now we have the seeds question. Okay, so I was explaining. I think Emma's left. Let me explain again. So we have to specify the seed of the account, just like this. So what seed am I creating the account with? You need to tell me if it's a wallet address of somebody or whatever. So let me use the seed, a word called seed, and I want to use the wallet address of the user of the signer. So can I have signer dot key, is it dot key or dot pub key dot as ref? Just get a reference for that one. Hold on. Then we convert this one to bytes because it does not understand seed. It does not understand the string, right? So convert the string into bytes. So now we're almost there and gone. So after we've gotten the seeds, we now need to specify. Now when we are on the curve, I talked about PDAs and curve, right? So how much space, how much further away from the elliptic curve do you need to go to create this account? For the love of Christ, we don't know. So we just tell Anchor, handle that for me. Bro, just handle the bump for me. I don't need to know what the bump is. Handle it for me. Basically, that's basically what guys living and joining again. So that's why we have bump here. So what is to complain about? Oh yeah, I understand. So now that's basically all we need to create this account. You tell it this account you're going to create it for me, right? Then the payer for the account is this guy. The space that is needed to create the account, we calculated the space already. Yeah, we calculated the space. This is 1 byte plus 32 bytes. So that's 8 plus 1 plus 32. Yeah, mistake here. So 8 plus 1 plus 32. Then we now say what the seed for the account is. It could be anything. It could be, call it count. Whatever string you want. But don't forget, the longer your ID, the longer the size of this struct and the more space you are taking up on your program. Then if you want to add a signer to it, so it will be specific to each person. That means if I'm coming to create this account, I'm creating the account with the word count as a byte and the key and the public key of this signer, basically. And I'm telling Anchor, yeah, derive the bump for me. I don't know how far I don't know because I don't know how further this account would be from the elliptic curve. Just derive it for me. But if I know what the bump is, I'll just say bump equals, I don't know, it's 25 or whatever it is, right? But I don't know what the bump is. So I'll tell you to derive it for me. But the problem now is there's no problem actually, but there's a problem. The problem is when you're creating an account, you need to also tell who is going to handle the creation of the account for you. And I told you yesterday that a regular wallet account, anything that the account factory, I can create an account on your behalf with the system program. So we have to do system. program, and that is a program account, the program of type info. Everything will have the info lifetime, whatever lifetime you call it, info. Then let's do system. Yep, and all our worries are disappeared. So now we have a counter account that will be created here when we're initializing it. Then the payer, then who is doing this, blah 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 blah. So now, assuming now I have an wait, let's forget that. Forget that for now. So what we want to do inside undo initialize is now let's do. But are there any questions up to now? Do you understand everything up to this point?
Yeah, I do. I do.
Okay. So the question now is how do we work with this? And we already know how to work with this. So instead of so the beautiful thing about this is if I was doing okay, let me try to write this up. Let's say let's meet counter equals self dot counter. Now I can have a counter reference directly here. Self dot counter, but this one will not work because I'm calling it as mutable here and I'm getting just a reference. So I need to mute it yourself here. Yeah. So and mute self. It cannot move out of self dot counter, which is via limitable reference. Cannot move. Am I moving it? I don't need to borrow a reference anymore. I just do itself. That was the problem. Um, so now I can just say counter. Counter is an account, right? This is an account. We specify the account is of
Yeah.
type counter. So everything that's inside that counter, we can create it. So counter dot
Uh, count.
yes, we have a
Current count.
current count and we have a my account, right? So we can do a counter dot current count equals let's start from one. And we can do a counter dot what's the next thing again?
Count.
My account is equal to self dot we have a signer here, ba. So we have
Yeah.
a self dot signer dot key. Can call that here dot key, not comma dot key. Yeah, so we have this, and that's beautiful, right? But instead of it might, if you want to initialize every state of this struct at once, there's a convenience function that's set inner. So set inner will set it for you as whatever it is that you created it for. So now counter is now equal to
One.
yeah one here, and my account is now self the signer the key. Yeah, I prefer to use this set inner since I'm setting everything at once. Yep. And now we have what this value has increased to. So let's after we've done that, let's now for testing, let's log out what the value of counter is now. Counter value is now counter dot current count. Yep. And I think yeah. So let's now. So if I wanted to do the same thing, yeah, this is what I would have done. But this will fail. It will fail. I cannot call these two things at the same time because I'm telling it to create the account. Yeah. So if I call handle initialize once, I try to call this handler again to fail because I've already created the account. So this init is creating the account. A better way for init if you don't want to create the account here, you can do init if needed. You can do this init if needed. So that way, the account exists already, don't create it again.
Yeah.
So
Okay.
and if you want to use init if needed, you need to specify in your cargo thermal.
Cargo. Okay.
Yes, and you need to put it in a feature So version is this guy. Then features is init if needed. Then features is init if needed feature. Yep. And that will solve the problem. If I come back to LibreRest, sorry, there was a initialize instruction. It's still downloading from the repo. Yeah, I thought I finished. So now I can use init if needed. So that way I can call these two things at the same time and it will not fail. So now let's fix this. What's the problem? So now we need to know what counter is, right? So let's counter is mutable reference, a mutable reference to ctx.counter, ctx.account dot counter. So that's the problematic thing about this one. This one you need to do uh,
Yeah, I guess the count the meat should be with the let's yeah.
but that's not the problem now. Cannot find counter. But yeah, I was trying to say the difficult thing here is that it's not like difficult thing for you to get whatever you need the account. You need to call it inside ctx.accounts. But for this one, it's inside self because it's an account already. So just call self.counter. You get so yeah, we're calling self. Yeah, we're calling ctx.accounts.counter before I get that counter. So that's basically what's there. So now for us to get the sign out, so we will do ctx dot accounts dot signer dot key basically. What's this error? Yeah, okay, can I have two okays? Yep, and there's an error. Cannot move out of context. I was trying to tell you that, bro. Mute ctx. Yes, it should be mute here. Let me see mute here. That's mute here. Let's mute. There should be mute counter here now. So maybe the ctx should be mutable on top of this one. And am I doing a mute ctx here? What's the problem? Oh, sorry. Mute. Start it. That should. That's not it actually. Let me relax and find the problem. I now move out of select account of is behind a mutable It is mutable, so I tell me I cannot move out of it. Move occurs because as anchor down counter which does not implement copy traits. Oh, my bad. I was supposed to just borrow here and that would have solved the problem. So now, yes, it should give me a mutable borrow. That's what I was looking for. Mutable borrow, yes. So I'm having a mutable reference to CTX account or counter here. I have counter here, and I'm just doing counter dot setting. So you choose your poison. I'd rather not choose any poison. Though. So yeah, that's it. So either you go with why is mute does not need to be mutable. What is the problem? Z. Z. Remove this mute. I remove the mute. You're telling me. I'll just leave it. Thank you very much. So either you go with this method inside the implementation, or you have this one outside here that you call as such. So now let me change the counter value to 2 here or to 5 here. Initializing. So when I come LibreRest, what's the problem? CTX account, which is behind the mutable reference CTX. Okay, that's why the problem was there. CTX undo initialize is doing something. Let me see, cannot move out of CTX account which is behind the mutable reference. Move across to CTX. So you could clone. I'm not cloning it. Let me do put this on top first. CTX account as type initialize. Use of CTX accounts is moved. Should I do a mutable account here? No, I don't need to do that. Let me comment this first. and still did not work. Still I can undo initialize. Oh, I was able to pass CTX here. Is that why? Text zero. No, I need to pass argument here. Let me see. Undo initialize CTX accounts moved due to this method call. If you move inside initialize. So that's what it was telling me here. Let me do let's counter equals a mutable reference. The counter equals
How far na Seyi? Seyi?
Godwin, your mic is on. Godwin. So counter immutable reference to let's borrow it here instead. Yeah, so I can get self here. So that way to not move to the problem again. Can imitate an immutable variable self. Cannot borrow self as mutable. I mean, I'm rusty on my anchor currently. So what is this one? It takes ownership of the receiver self, which moves. I have to even figure out where the move is coming from. Self dot setting setting. Okay, I think it's this guy. It should be probably this guy. Nope, not that guy. Mutable reference of self dot counter. So counter here is mutable self itself takes ownership of receiver self, which moves CTX accounts. Welcome to Rust, guys. Let's see. What is going on? And the annoying thing is this the solution to this thing is something very minute. I'm going back to you. CTX account. How to move out of CTX account, which is behind a mutable reference. If this will not be mutable, okay, I think I get now. Initialize. So if this should not be mutable, should actually be mutable though. Let me remove the mutability here first. Reference self. Consider changing this to mutable. Okay, I know what I'll do. Borrowed reference to mutable. So yeah, I think that's not the problem. I should have borrowed a reference to mutable, not just mutating it right off the shelf. That was the problem. I knew it was something simple. Yeah, then we can uncomment this guy. Now we have the same problem again. So what's the problem now? So I moved CTX here. So let me do uh yeah, so that works. So I first used it here, then I moved it here. Let's now see if we build this program anchor build. There should be no errors though. One hour 26 minutes. I work with me, no time, no time, no time, no time, no time. The reason why it's rebuilding this stuff was because of the initiatives needed that we installed. Yeah, so built successfully. Then our test needs to be updated. Now, if you go to your tests, it's not telling us that there's a problem, but there is a problem somewhere. So initialize is not taking anything actually. But is there a problem? Yeah. Let's see. Let's see. It might work, but I don't think it should. It should. Anchor might create the account for you already. Let's do Anchor deploy. We just built already, right? Anchor deploy. Bro, just anchor test. I don't test my head. So to build it, to deploy it, and to test it. I'm thinking that it would fail because we not specify the account that we working with here. Need to take his account and to ask for the signer. Yes, the fail. Need to specify who the signer is in this case, and also yeah, we need to specify who the signer is. Then since the signer is my account, this test should fail. Should it? Should it not? Should it? Should it not? Oh, it actually passed. The reason why it passed is because the signer that we're asking for here is already the signer automatically. So Anchor is already deserializing that signer for us automatically. And the reason why the other account, that is PDA, what do we call it? We called it initialize. We call the account counter. Because now we are creating the account. Even if I don't pass the account, I've already told Anchor everything that is needed for this account to exist. So to compute the accounts for me based on what I've created here. If I change this to mutable, yeah, I don't need to put space seed. Okay, let me do this. Let me just remove space. Payer is signer. Unit must be provided. Okay, mutable. So if I did this now and I build again, if I build now, I should have one error in my tests. Let me remove this one first. Okay, signer, and now it should ask me for. It's still not asking me. Wow. It should ask me for. It's only signer is asking me for. Okay, now it's asking me for signer. And I had to put. Should actually ask me for the second account. I don't know why it's not asking me, but let's one problem at a time, right? I don't need to create a problem that doesn't exist yet. Yeah, so where's what we're looking for? This was the transaction we sent previously. Let's check the Explorer if you went through. Yeah. So we had counter value. This was the first time we created the account. The second time we're coming to the account, but now we're not creating it. We are using it if it does not exist. And now we have 14,225 compute units out of 200,000 compute units. So majorly our logs are taking more space, some space. Yeah, so that's basically that. Let me try it again. If I try it again, it will still work. Let me move the accounts for now. So Anchor is already handling all the accounts for me. And I know why. I know why. When I do call.rpc here, and I'm not passing in a signer or an account. If I'm doing signer, the signers that way, I would need to pass the account. If some account are signable, some accounts, yeah. So now if it's asking for just signer too, but if I do account partial, that way I'll have to provide all the accounts. So now it will not even know about here. So this way it will ask me to provide counter, signer, and system program. So if I want to provide everything exclusively, even though Anchor will see compute it for me. But since Anchor is computing it for me, let me just use the accounts and leave Anchor to do the rest. So we don't need that. The reason why we don't need that now, but we'll need it soon enough. If I let's make us need it. Let's do let's do an account here. That will be the signer. So instead of using my own base account to sign my own the account on my PC to sign, let's create an account here. So Solana keygen new. Then the output file is, let's put it inside test and inside a folder called, let's create a folder inside test, a folder called keep it, call it accounts. Inside a folder called accounts. Yes, so test accounts. Then let's call it user1.json. And I don't want the private key to, I don't want the key pair, the seed phrase to be out in the terminal. So I'll just use a silent mode. So Solana key gen new silent mode and where I'm setting the account to. Yeah, so it created a new account called user1.json inside account. So you see user1.json here, right? So now I want to use that account here instead. Import user1. Let's call it user1. User1 from the JSON file. We need to do some whatever then from inside accounts. Then inside accounts we have user1.json. But yeah, there will be an issue here because we need to have resolve JSON module inside our CS config. I don't import a JSON module directly. We need to specify that true, and this should be string. If I save that, that should have fixed. Yeah, that fixed the problem. So after we have the user account now, and I want this user to be able to be the one signing all the transactions here. The first thing we can do while we're setting things up is specifying const user1 key pair user1 key pair. I like using camel case, please. User1 key, sorry, snake case key pair is you can use anchor. Sorry. Let's just do keep anchor the web3 dot keep is it keep yeah keep dot from secret key I think with secret key or whatever we'll know in a minute. So and that file is yes user one as just do is that expecting what expecting a uint 8 array. So use uint 8 array the from I'm just importing that guy there as a unsigned integer 8 array. That be what I'm doing. So now we have this keeper. So we're creating the keeper. We're importing the keeper directly from this file that we have locally here. And mostly you want to ignore it when you're pushing to GitHub, right? So yeah, I want to ignore what is inside test and keep account s. If I save this color should change. If I save this, yes, the color change grayed out. So I'm not tracking that on GitHub. Yeah, so now we have the user keeper. So let's try to airdrop something to the user. Solana airdrop one to this guy to I don't know what the user account is, right? So let me just derive it from here. That's what I was telling Solana address. What's the key to the address is inside tests accounts. Whatever the name of this guy is. Rename user1 JSON. Yeah, so Solana airdrop one to this guy. So I want to request one airdrop to that guy. So it's a request one airdrop if he decides to go. Airdrop failed, rate limit reached. We'll try again. Yep, and it's sent. It's already gotten. So this guy now has some address, has some balance, right? But we can do that programmatically too. You can request airdrop inside your test, but that's not what we're doing now. Let's just assume that the tester already has some account, some SOL. So that's what we did here. We already airdrop some SOL to the user account. So now I want this guy to be the signer for the transaction. Yes. So now I can do dot signers and I can put user1 keeper there. User1 keeper dot secret, no, it's a signer, not the secret key. Yeah, so that's the signer. Then inside the accounts, I want to pass some accounts to it manually now. So now it's asking for the signer here. I can tell you who the signer is. I can tell you who the signer is. The signer is this user one keeper dot pub key, public key. Save that. Now I'm manually telling it use this signer, and this is the signer here. So don't use the signer from my local environment. The reason why it has access to my local environment is because of that's the other guy. It's because of this nigga here. First, I'm telling it the wallet to use for all transactions here is this guy, right? So assuming I want to use this same guy as the guy inside test, the one I created now as the okay, yeah, as the as a signer, I'll just pass the directory link to that directory here. But let's still leave my local wallet as the deployer. But now this is on actual user, and now I just cheated my account. So it's DevNet though. Um, yeah. So what was I explaining? I was explaining test. Okay. Yeah. So let's now test now. So we'll see previously we saw that the transaction signer here was a CZ because that's my local wallet here, CZ. But now when we're doing the transaction now, it should not be a CZ, it would be a anchor test skip build skip deploy skip build skip deploy. Yeah. Now the signer will be this guy and what's the guy address? Let's check the guy address. Let's check the guy's address. Let's check the address here. Over here, it should be GB. So GB is the address now. So let's check the signer for this transaction. This transaction signer should be a GB. Not you. Should be a GB. And we should see, yes, the signer is a GB. And GB is the one paying for the transaction instead of my own wallet. So now we have the same program worked. And the reason why it's working now is it works basically. And we changed the signer and everything works as it's supposed to be. So this is one way to have your a local key. If you have a local key pair as the signer, you can import that here. And you can just basically just spin up a new account. If you want to do that programmatically, you can do spin up a new account here every single time. You spin up a new account. Then that's from anchor.web3.keeper dot generate can generate a new one. It will give you a new keeper. You have created a keeper, then now you want to airdrop to that keeper. So airdrop to that account. You can do, I think is request airdrop. Request airdrop should be from, I think let's do anchor dot connection the connection the web3 dot connection. That's the request airdrop connection. The request but you can request airdrop. I'm not going into that. Let's see. Let's RPC. I'm not doing that. Yeah, that's far from what I'm doing now. So you can request airdrop and just continue the line of instruction, stack them below each other. That's 1 minute. Yeah, I'm back. Noise was getting too much. Yep. So now let's get to write another instruction to increase the counter. So now we have an instruction that initializes the counter, right? So now let's clean all of this out. Let's keep it as init. Let's keep it as init. Let's say who the payer is, what the space is, and who is signing for it now. So now we're getting into more serious business now. So let me remove this guy. We don't want to show the different methods again. We now know what the different methods are. I can remove this guy also. If I build and deploy, so Anchor test now should throw an error. If I test it to build, to test, to build it to deploy and test, but now the test should throw an error, and that is mildly because you will see what the error is. Right? So let me tell you what the error is. Okay, deploy, take your time to deploy. Send in 208 transactions. Send 208 transactions. Okay. Yes, I see what the error is. So the error now is this address. This is the PDA that was created for us. It's already in use. Why? Because we called an instruction initially that already created the account. Yeah. So for some instances, you want to not recreate. You want to not call one method once it has been called. Let's say you are building a program logic that is an AMM or something that is a store for a configuration. Let's say you are building a DEX now, a trading program, and you have already set the configuration there, and you don't want to override that configuration once you have set it. So you can just put it inside the init. So yeah, initializing it one time. Cannot I can now have a different method to modify it. That one you know that you're intentionally modifying it. But if you have created it initially, you don't want to recreate it, right? So that's one way to do that. So this would fail. That's good. So if you want to escape your failing test, let's say you have a test, you know that this test will fail. If you want to skip it, you can do the skip. It will skip this test for you. And you can also do XIT. Well, I'll comment that. I don't need to build and deploy again. So anchor test, skip build, skip deploy. Yeah. Yes, and it will keep that test. So 0 passing, 1 pending. You keep it as pending, right? Same thing with XIT. If you don't want to use it or skip, you can use XIT. All these are from Mocha XIT. So if I do this, it's also skip. So to skip that test, right? So let's get into a different instruction. Let's see. The next instruction is let's create an instruction handler here, and let's call it. You know what? Let's just modify this one. So we call this undo initialize, right? So now the next one, let's just call it pub fn increase counter. Undo, I like calling it undo increase increment, undo increment. And we're taking a mutable reference to self, and we're returning a result, and basically that's it, right? So now let's do this is basically moving around stuff that way. Okay, let me write it. I'm just showing you that you can have this one here, and inside, assuming I have this, I just return it okay here. If I have a single okay here, I can come inside my librs, create a new file, a new handler, sorry, a new handler, and let's call it increase counter. Increase counter, and to do this counter, assuming it's still inside the initialize, and I will do ctx.accounts dot undo increment. So now we have a different function called undo increment, right? That works too. But now, instead of, I want to show you, let's keep it modular, right? Let us put it here because we don't want to use the same. We could, but now because we are initializing the account, it will fail. Now I want to create, to bypass that, we can use init if needed, right? But let's do a more professional approach. So inside the counter now, we want to do something inside our counter. We want to also store the bump. So the bump of the account is a U8 basically. So the bump of the account is a U8. Then, then. So let me change this to counts because I might have some issues with it because of the account that was created already. Counter now. So the bump here, I want to set the bump of the account because I'm telling you to create a bump for me here. How do I get this bump that was created? If you are creating any bump inside your account, you can get it's because Anchor is helping you create the bump. You can get it from a bump handler, a bump helper. So it's just basically the name of your struct and bump that will be initialized bumps. You can get it from there. So let's call something bumps is of type initialize bump. So we have a counter. The bump is bumps dot counter. Simple and straightforward. Does that make sense? Because the bump is for this counter account that was created. So you can handle that, you can get that from inside bumps dot counter as a struct of initialized bump. Does that make sense? Does it? Questions, answers, subtractions. We are good, right? Okay, so let's continue. We are halfway there. Any questions? Godwin, you are good, right? Everybody's cool. Let me remove this one. I don't need this anymore. So the reason why I'm saving the bump now is the next time
I
I'll
actually
show.
wanted to ask why you are saving the bomb.
Yeah, exactly. So let me show you instead of answering the question. Let's show, not tell. I can show and tell also. Um, minutes, minutes, fish. Okay, sorry, I was reading a message in Discord. Yeah, so let's create a new instruction here. And let's call it modify bump, modify count, modify counter dot rs. So we need to keep track of this modify counter dot rs also, right? It's an instruction handler. So we use pub module modify counter. Then we use pub use it publicly modify counter and everything inside it, right? Every single thing inside that modify counter instruction you want to use. It will give you a yellow line because there's nothing inside the modify counter instruction right now. So what we want to do is simple, the same thing we did before. So now let's create a struct for the instruction handler first, for the accounts. So let's call it modify counter. So this one's an account. Yeah, basically. Then you should take in an info, lifetime. We need to use anchor prelude here also and get in. Use anchor prelude, anchor lang, prelude, every single thing from the prelude. Increase the file size of the binary. So now let's first thing also for every transaction you're sending, we need to know who the signer is, right? Because we want to use the signer somewhere in the future. Bob signer, I call it payout, I call it signer, but since we started with signer, let's just stick with signer. You get the signer struct, and that you have the same lifetime info and Bob signer info. And we need to tell, okay, we can come to this constraint later. Then the second account we need is, or the second account we need another account, that is the counter account. So pub counter is of type account, and your account is info and counter, because counter is the account structs that we created, these accounts that we created from the state.rs. Yeah, modify counter. So now this is basically everything we need. Simple and straightforward. So you can now have an implementation. Implementation, taking the info lifetime of modifier counter, which also taking in the info lifetime. And we have pub a function that let's make this one increase, undo increase, undo increase. sure. And the next one will be undo decrease, right? On Friday's live stream will be you guys doing the writing the code, undo increase. This one will be undo decrease, undo decrease. Yep. So inside there, I'll just return an okay. So that error will go away, right? Okay. So I already know what our struct is like. So now let's get to the constraint of these accounts. Mute. So we need to tell it that this is an account, and what are the constraints we want for this account. This account now needs to be mutable because we want to make it sign transactions. Yep. So what's the problem? Account, blah 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 blah. Accounts. Is there a problem here? We say external macro, found macro account. I don't understand what's going on here though. Let me see. Accounts. Oh, I forgot to do a derive account. We need to derive account here first before we can use the account macro inside it. That's basically what the problem was. Yeah. Can it? Oh, my screen stopped sharing, and it should be back. The next 5, 4, 3, 2, 1, share. Okay, you can see my screen, all right. So we needed to use this account macro before we can use this singular account mutable. Yeah, that's just basically what the problem was. So now we'll do, yeah, also this was also an account. This is also an account. And we need to tell what are the constraints of this account. So now this one is a mutable account, basically a mutable account. And because we have saved the seed somewhere, we have saved the space. We know what the seed is, basically. The seed is from, where is the seed? Initialize. So this is the seeds. Can copy the seeds. Mostly you want to have your seed somewhere, so you can just reuse it as a function, global variable. So we have the seeds, and now we need to specify the bump. But because we have saved the bump before, and this bump we have saved it inside the account, this account that we're passing has an information called bump. You can just call it directly here, counter.bump. That saves our lives, a lot of stress. And that way, Anchor does not need to derive this account again. So it will not create or do this computation. No, I told you how accounts are created. Now, to do a for loop from 255 to 254 to 253 to 251 until it gets to 0 to
Yeah.
derive the account. Yeah. So instead of it doing that one, since you've already created the account here and you have saved the bump inside this counter account, when you're passing the counter account the next time, you can just use the bump that you have derived there. So that way you don't need to use anchor bump whatever here again, because it will not even work. If I try to do, yes, taking in a self, let's take in a and mute self. Yeah, now say bumps is modify account bumps, modify counter bumps. Okay, it's working now. Because I'm specifying the bump here. Yeah, so we can do that too. But I don't need to use I don't need to access the bump anywhere. Or let me see. Let me check. Let me just confirm. Bumps dot, yes, it will not work because it's not creating any bump for me. Assume it's creating a bump for me to create it and inject it here, but it's not creating it. I'm not specifying. I know all the bump is already, so it will not work. That's what I was trying to point out. So this one will not work because I'm not creating the bump. I'm using the bump that I've already created. I don't need the bump anyways for this instruction. I'm not doing any transaction on chain yet. So now, what do we want to do? We just want to increase the value of the counter, right? So we can just do is immutable reference to self, right? So self dot counter dot count current count plus equals 1 Stephanie. And inside this one, we do the reverse, self dot counter minus equals 1, taking in a mutable reference to self, mute self, and voila, we have something that can increment and decrease the counter. Simple and straightforward, right? So, but what's the but? There's no but. Is there a but? There's no but. I don't think there's a but. No, there's no but. So I'm going to go. So let me just log out the what? So message counter value. We are going to clean up all these logs when we're done. But for now, let's just see what we're doing to for sanity of things, right? So counter self dot counter. So here also, since we increase it, if we decrease it here, we also need to log out what the counter is. So that's what I'm trying to point out is now we are already taking it as mutable because it has already been created initially. So it is now mutable, right? Then we pass in the seed that we used to create the account initially, then the bump for that account that was created, the bump that was used to push it off the elliptic curve. And once we have all of that, yeah, that's all. So inside our instruction handler here in the librs, yeah, what's the problem here? What's the problem here? What's the problem here? Argument of blah 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 blah. Blah. Okay, yeah, it will throw an error because it needs to know what the bump is. So check here, you will see that I'm expecting self and bumps, but self will be automatically injected. So I need to provide bumps, right? So now let's do bumps. In this case is now ctx dot account, no, ctx dot bumps. I think, sorry, just a variable. It's not an struct. So ctx dot bumps. Yeah, that will solve the problem. So I'm just passing ctx dot bumps inside this undo initialize because it needs the bumps. So for this increase counter now, where you have an increase counter. So now the context here is no more initialize. Now the context is modify counter, right? So an undo is called undo increase. Oh, we did undo increase. Then the second one is called undo decrease. Simple and straightforward. Decrease counter. Yep. So now we have one function, so one method to initialize the counter, another method to increase the counter, and a method to decrease the counter. So let's go. We need to run those three tests. So now let's get to writing our test. Let's build first to show that there's no problem. Anchor build, it should run smoothly. Then let's come into our counter object. So now we need to initialize this one because we changed the seeds. We're not using count anymore, we're using counts, right? So initialize, that's this the test for initialize. We want to do on that test. Let's call it should increase count. Then let's duplicate this and call this it should decrease count. Should decrease counts, basically. Simple and straightforward. Just have to create a function like we do in include and decrease, but now we have to define an account and the person that is signing. Yeah, I'll come back to explain that question. 1 minute. Let's test this first. So should increase count, we have program dot method. Now we are looking for the increase counter method here. Now looking for the decrease counter method here. So now we have to still pass because why is this thing messing with my head? It should fail. It should fail woefully because we're not passing the account that we're creating here, or because it is creating the account for us, it will just increase it because we're telling it everything that is required to create the account. I think they did some modification to Anchor and is now resolving the account better. Previously, you would have to pass the account to the account structure. This counter account. Previously, you'd have to pass it also with these seeds. But now it looks like Anchor is handling all of that for you. Previously, you'd have to do, let's enter the test and let me show you what you have to do. So yeah, you create the, let's just derive the account. So let's counter PDA, counter PDA is anchor dot web3 dot pub key public key dot find program address sync. So I'm looking for, this is what we do. This is how a PDA is derived, right? So the seeds for creating the account is first string. The first seed is what counts, and the next one is the user one keeper the pub key. I'm coming to that. User one keeper dot public key dot to by you can use to buffer, you can use to bytes. Since we are converting into bytes, let's use to buffer. The function and it's the same thing. So we need to use this one too has to be a buffer, right? So there's a buffer method, a buffer construct. So can I do buffer dot from, so it converts this count into buffer, right? So what's the problem now? Expected two arguments got one. So this is the seeds. Then which program ID is creating this account for you? So that is our program ID. So we can get that from program, this program here, this program, and we can have a dot program ID on that, and that will solve the problem. So if I log this out now, it's also the log counter PDA, and it's mostly at index 0. This will give you an array. It will give you an array of the account that was created and the bump. So I want to log out the bump at the account that was created at index 0 now. Right. So let's do that. That's how to derive an account. So then we will now pass the account here. What's it called? What's called counter, right? Counter is now counter PDA at index 0. Counter PDA at index 0. But this will throw an error because it does not expect you to provide counter because it's already doing it for you. But if I use account partial, that way it will need me to provide counter and it will need me to provide system program. Okay, we're not using system program here, right? So for that, let's see. So we should increase the count. This is how to drive a PDA. We'll do anchor web3 pub key find. It's just pub key find program. And this web3, if you installed Solana web3.js, you would have this web3 directly instead of getting it from inside anchor. So you can just get public key from, you can do, if you are installing that, you can do import from at Solana web3.js. Then you can have pub key, yeah, public key. But since it's inside, Anchor is re-exporting it. So let's just remove that and use the one from Anchor. It still does the same thing. So now let me just run only this test. It should fail. So I can do dot only on it to make sure that's the only test I'm running. So if I do Anchor, it will deploy. Let me run Anchor test. It will fail, but I want to show you that a PDA was derived. I want to log out this PDA that was derived. Derived PDA. So it's still deploying the program. Once it finishes deploy, yeah, sometimes deploys fail. So let's deploy again. Anchor deploy. And most things is that if your deployment failed, some amount, the amount that was used to pay that gas, so don't worry, forget about that for now. Let's just continue deploying. So we've deployed. Then let's test. Anchor test. I've skip build. I think I have this written somewhere. Yes, skip build, skip deploy. Yes, to fail, but it should give us a derived PDA. So it derived the PDA for us based on the seeds that was specified, right? So cool. So we want to do, let's do the same thing for decrease counter too. Because I'm using account partial there. So let's do, I also want to show off that you can create your counter PDA and pass it even if Anchor is shouting at you that you don't need to pass it, you don't need to pass this. But no, I want to pass it. But let's pass it. So that way, same thing. I'm I'm finding the program address sync. I'm not creating it here. I'm just looking for it with the seeds, right? The seed is count. First seed is count. Second seed is the public key, and that is from instruction. Sorry, yeah. First seed is counts. Second seed is the signer key, signer public key. So that's basically what I'm doing here. Also, first seed is count. Second seed is the signer public key. So now let's do all the tests at once. Let's see which will pass, which will fail, and why which is passing and why which is failing. Then I think all should pass though. I won't hold my breath to that though. So let's see anchor test. Skip build, skip deploy. Let's go, let's go, let's go, let's go. Failed, failed, failed. Three of them failed, right? So what's the first error? Account not initialized. Yes, that one will fail because the first account. If the first one failed, everything else will fail. Is initialized. Why is it failing? Account did not deserialize. Failed to deserialize the account. Brother, you told me not to pass the account. Why are you telling me you failed to deserialize the account? Why? Let's do the same thing here first. You told me not to pass it, and now it's throwing an error that the account does not exist. And the account does not able to deserialize. Let's do account partial here, and let's pass in the account. So let's call the second one is counter, right? Call counter PDA at position 0. Then the next one we need to pass is the system program, right? If you check our instruction from where is that? Initialize. You see, the three accounts are passing is signer first, counter second, and the system program. So you need to pass the system program also, and that is a global variable. You can get that from inside Anchor. Yeah, so this is the system program. System program is 11111111. So we can use where's that counter then system program. System program system. Fuck, this is a type. This is a type. This is okay. This is a type. Want to do system. Where is it imported from? Is it from? Let me see. Programs. There should be a programs. Program account provider. Blah, blah, yes. Okay. Let me just type this out first. Where is system program account? Let me start typing system program first. Yes, system program ID from yeah. So we have it inside this native system BS, wherever it is. So we already have system program ID. Now let me put that here and save and no errors, right? So now let's hope it works this time around. Yeah, so let's fingers crossed. Let's see, let's see. Failed again. So now it's still that same error. Account did not deserialize. Error failed to visualize the account. So there's something wrong with the account that was created. Let's check initialize account. Count signer key as ref 8 plus 1 plus this. Then we're doing a set in a minute. Self dot signer key bump is this. So why is it not serializing the account? Current count. What are we doing a init? Are we doing a init here? I said the signer space 8 plus 1 plus 30 might be something to do with the size. Let's check. Let's check. Might have something to do with the size. You can check the size. Yeah. Let's just use 8 plus counter in its space. That might be what is causing the problem. Since if that was causing the problem. Yeah, let's do that first. Then do anchor test. Why is it failing to visualize the account properly? Info counter. Counter is off. Counter, yeah, counter is an account, so serialize properly. Account current bump. Yeah. Let's see. Let's test it again and see what's going on. Mm, deployed successfully on our test. Yeah, so that was the problem. The problem was the size of the account. There's something wrong with how we're calculating the size of the account. And now we do have all three tests passing. So initializing the account, I copy this and I go over to the Explorer, paste this there to tell you how it created the account, right? The logs that were emitted mostly, yeah, we created the counter with value one. So the next time we're coming to counter here in the transaction hash, second time we're coming. So this was the transaction hash for increment counter, and that one should give you a value of two, correct? So decrement counter now should return the counter value to one, if we're not mistaken. And decrement counter should return the value back to one. So yeah, all good and fine. So we have a working counter example now. The any questions on that part? Godwin, questions, chat questions, everybody questions. This is just are getting started, right? So this is the starting point of if I have questions, yeah. Let's answer the questions first before we move on. Okay, the chat. Okay, okay. All right, so Godwin, your question was I thought we just had to create the function like we do in JavaScript to increase and decrease, but now we have to define the account and the person that is signing. So yeah, like I said, you cannot store things on the blockchain. So to say, everything has to be in his own folder, his own file. So you have to create a folder to store something. So the folder you are creating or the file you are creating is your account. So your account is what you are going to store. So this is the account that we created. This is the file we created now. The file has a type of counter and it can store current count, it can store his account, and it can store a bump. So this is the one account that we created. So this is the blueprint for the account that we created. Then we have mother-s. Okay, we have the initialize instruction. This is where we are creating the accounts initially. So we're just doing handle initialize here. Say straightforward. We are setting the struct because it's a mutable guy. We are setting it as mutable. So when anything we set here, we will update the value of this counter. Yeah. So yeah, that's what we're doing there. Then the second one was modify counter. So everything about modifying the counter value, handle increase, handle decrease, basically all that sweet stuff. So I will. Okay. Any other question? Do you have any other question? Got it. What did I say? So like I was gonna for that one. You can use your mic if typing will take time. Because I see that.
Okay. Can you hear me?
Yes, I can hear you.
Okay, where I am is kind of noisy. That's why. So basically, I understand the whole thing. So normally, we use localhost and console logs in kind of storing your state in JavaScript, right? So is it the kind of thing we are doing here, but rather we're using accounts on this aspect? And that was one. And secondly, I want to like get the flow, right? I think I ran my test when building this, and then it worked. Sorry, I ran the build, it worked, and then when I ran the deploy, I now saw the error of the localhost issue, which is said we changed to DevNet, right? So I want to know like how the folders con- communicate, like how do they move, like the flow from initialize down to the state down to yeah, that kind of down to the lead, like that kind of flow. That's like my question.
Okay, cool, cool. All right. So the first thing I would say is run yourself. Accounts. Okay, first thing I would the reason why I said you should change it to DevNet is because I want to be able to monitor it in real time over an RPC connection. So I'm sending the transaction online to the DevNet environment and I'm checking it here. If you were using localhost, if you wanted to use localhost, you would have done something like this. Let me do it. CD. So I'll do Solana local validator. Is it Solana local validator? No, not Solana. What's your name again? Local validator. I'm coming. Let me check. Solana. Solana test validator. Yeah, Solana test validator. I create that one. Now I'm creating a blockchain RPC instance on my laptop. So it's initializing it right here. Once it finishes initializing, I can now connect to this my laptop node and deploy the program on this node. But that way, nobody can have access to it because I'm the only one that have access to this node. So now this one will work. So, but I don't want to set this up. That's why I said you should just use DevNet directly, right? So that's why using DevNet first thing. And the second thing, your second question was how does it all communicate with each other? Like I was explaining yesterday. Did you go over the video again? I said you should go over the video yesterday. Everything on Solana is an account. That's why. Okay, yes. Everything on Solana is an account, and it is accounts that you store stuff. So in the Linux file on the computer, you cannot just store something on your laptop without putting inside a file, right? You have to create a file for it to be inside. It's an MP3 file, MP4, a doc file, a PDF. You must have a file. So you're writing to that file. You're not writing to your laptop. The file will now stay on your laptop, but you're not writing to the file itself. You're not writing to the laptop. You're writing to the file that you now save inside your laptop, right? So that's how it is on Solana too. So you need to have a file. So now, first thing is we're creating a template for what our file will look like. I think my PC wants to go off. Sorry, my monitor. Yeah, back on. So we're creating a template for what. So that was inside a state. This is a template for what our file will look like. Let me give you an example of. Let me create a local file. Let me just show you a normal file. Downloads. Then. Coming up, looking for a file that I can show. Okay, let me use my smiling picture. I have this image, right? If I right click and I can check the properties of this file. Exactly. If I want to check more detailed properties, I can see the size of it. So this is the template of what the file look like, right? The aperture, or the exposure, or the focal length, the ISO, the metering camera, the date, time. Those are the details of what this file is about. So that's basically similar to what we're doing on Solana. So everything is a file, right? So this one is a file that I cannot write. So this one is a read-only file because I've already created this picture. You cannot edit the picture. Only if you want to take it out somewhere, copy what is inside this file and work on top of it. It's like in Photoshop or something. But this file as it is a read-only file. But if it's an executable file, like a Microsoft Word, like this your lib.rs, I can easily enter and just type something inside it, right? That's a file that's editable. Right. So now everything is a file. So you have to specify what kind of file. This is the kind of file I want to store on the Solana blockchain, right? I'm not even storing the file on Solana blockchain. You are paying Solana to keep track of that account for you. You are storing it inside the file. Then you're telling Solana, okay, this is the amount. Let me create this file, and this is the data I want to keep inside it. So you now pay it for writing the data for you inside that file, right? So that's basically how it works. So this is the file we created, and it's an account. So now you understand that accounts are files. Just that are files. So we created a template for an account, and we told the compiler that this file should have a counter. It should have a current count. It should have the owner, the account, and it should have a bump. Basically, that's what you're telling Solana. So now, inside our instruction handler, we're now using Anchor to undo creating the files. So undo initialize. What we are doing in initialize is basically just creating that count. So this was creating the count. This was creating the file for us. This init constraint. If you check what this init does internally, can it load up? Can it load up? It's not loading up. I think I'm clocking something on my CPU. No, I'm not clocking anything actually. Let me see what is yes set account. Macro. The init. The init. Proc macro. proc macro. Then is there init coming up? Init, init, macro definition, init. I'm looking for where init is. So you see exactly what it's doing for you. So if there's an init inside your macro, I think yes, we're getting closer to it. Init, init, init. Okay, I think it just passed one. Is there init here? Okay, not directly here. It's not here. It's inside Anchor program. This is not Anchor. This is Rust lib. So not proc macro I was looking for. I was looking for, let's check. Let me see. 46 inits. Can I go through all the 40? Okay, yes. So if there's an init inside it, this is what it will do. It will create an account for you via CPI program and initialize the program. So this is where they are explaining how what will happen when you do init. So init is creating the account for you basically. But that's, you already know that. I just wanted to point out to how it's done, but it's not shown here, right? So you're telling Anchor, this account, oh, I've told you it's an account, right? So you're going to create it for me. You're going to initialize the account for me. This is the person that will pay for it. This is the space of the file. Like I showed here, there's a space for this file, there's a size for this file. This one that I opened now, there's a size for it. Yeah. So the file size is 32 kilobytes. Yeah. Same thing with this guy here. So you need to tell us what the space of this guy will be, of the account, because we already know what will be inside it now. We already told it that what should be inside this thing is U8 1 plus 32 plus 1 plus 32 plus 1, that's 38. Sorry, 1 plus 32 plus 1, that's 34. That's 34 bytes. So I'm telling it the size of this thing is 34 bytes, 34 plus 8. So that's the size of it. Okay, I think the reason why it was not working before was you're supposed to do 8 plus 1 plus 1 plus 32. That's why we missed the second one. That's why it was not working. But you understand, sir? Yeah, so you tell it the space that is needed for this account to be created. Then what are the identifiers you want to use to create it? So create it with something that you can use to find it later on. So you want to create it with a seed. The seed is the count, and the person that created it, the wallet address of the person that created it. So that's it. You have this account here. You are telling me create this account for me. So what it does is, once it creates the account here, from here, you are now coming inside here and writing into that account, because it's an executable file. You're writing to the account. So let me look for the account. That one of those accounts that was created now. So the first instruction was created. Okay, the account that we created was, I think, is this F2 Nike. If you check Solana account now, if you inspect this account, Solana account, paste this here. If you look into this account, you see that there's data inside of it. So this is 42 bytes exactly, because we told it to create the account with 32, whatever the size of this was. This 32 plus 1, 33 plus 1, 34. 34 plus 8 is 42. So that's how we have the length is 42 bytes here. Simple. And this is the data that's inside the account. So simple and straightforward. So it's writable. You can write to this account, but there's data inside it. Somebody can write to it, but it's not a program. You cannot execute it, but it's a writable account. So this is the data that will put inside the account, basically. You understand now? So that's how the account structure is on Solana. So you create an account that you can write something to it. Once you've written it, you can do whatever it is, a file basically. So you can write to the file, you can read from the file, and yeah, so that's basically what we did. We'll come to the instruction librs again. We initialize the account as we created the account. Then we are writing to the count variable inside our account that we created. So we are writing to it. First time we're increasing the count, second time we're decreasing the counts, and straightforward. Understand? Do you understand now?
Yeah, yeah, it makes sense.
All right, cool. Any other questions from chats from everywhere around the world? Let me see. Let me check if there's anything on. I've never checked the chat all this while. Chat. Okay, I'm looking at chat. 1 minute. Let me check Twitter for chats. For chats. For chats. For chats. Hmm. Yeah. So there are no questions, but we are already 2 hours. We're 2 hours 30 minutes in already. So should we go on
Yeah.
to yeah the question?
Sorry, my last question, last one.
Yes,
So
you can
yeah,
ask question. Ask as much as possible.
yeah. After I initialized the Anchor project, right? It gave
Yeah.
me a key. I'm actually looking at my project. It gave me a key, but you said
Mm-hmm.
something that is after we had deployed our program. That's when we're supposed to get that key. Is it that when we deploy, we're going to get another key, or we're still using that key?
So
Um,
what? Yeah. What is happening there is once you create an Anchor program, once you initialize an Anchor program with Anchor in it, it gives you where the account, the key. I told you, you are writing to an account. So it gives you an account to write to inside your target, deploy, and the name of the account here. So to give you where you want to write your data to, and the ID for that account is this one. The wallet address for that account is this one. So that's basically what's happening there. So it will give it to you, but nothing exists inside it yet. It's still offline, off chain. So when you create the account and write data to it, it now becomes a program, a valid program ID. So if you've not written anything to it, it's still a wallet address at that moment. Once you write something to it now, so if I copy this guy and I copy this guy and I do Solana accounts on it, Solana accounts, and I paste this guy, you will see is executable. Yes, because it's a program account that I can write to, and the length is 36 bytes of this account. Then the space is 36 bytes, and this is the data that is inside of it. Yeah, so that's it basically. You understand now?
yeah, yeah, yeah.
Okay, so no any other questions before we call it a day?
No, no, no. I'll just go through it and get more understanding.
Yeah, roll it back, roll it back, roll it back, roll it back, roll it back. Watch it as many times as possible before we get into tokens. We can do tokens. I don't know how tomorrow will be. I also want to clear all the doubts about the fundamentals as fast as possible before we get to we might do that tomorrow. Yeah,
So,
yeah,
what about the connection to the front end?
yes. So connection to the front end is what you will basically use what is inside your test here as a starting point to what. Okay, let me just use. I want to just quickly use. Let me see if I can quickly use AI for that, or should we properly do it tomorrow? We
Yes,
use.
let's do it tomorrow.
Okay, so it is basically these guys that are using. This is TypeScript now, and your front end is in TypeScript also. So you already have what to write with TypeScript, but there's a slight difference in on your program. Your key pair will not be hard coded on the front end. Your key pair will not be hard coded. Your key pair will come from the wallet connection that you have. So we can get to that tomorrow then. Let's see how tomorrow it goes. Right. So thank you guys for staying. If you have other questions, you can hit me up on Twitter. I will definitely reply to your questions. And yeah, it's been an amazing 32 minutes. And thank you all for being here. This was and this is the Anchor founder. I'm trying to give me a minute. That's not yet. I'm not done yet. I want to share. I want to share something. I must share that thing before we go on. So yes, this has been the Anchor founder, and we'll catch you on the next episode, right? Yeah, guys.